We are solving two simple questions that appeared in NEET in the chapter atoms. Let us see the first question. If an electron in a hydrogen atom jumps from third orbit to second orbit, it emits a photon of wavelength lambda. Let us stop here for a second and see what's the meaning of that. We know whenever an electron is in a particular orbit, it is an energy h nu, because it's electron jumped from one orbit to other orbit, it emits a photon with energy h nu, that equal to hc by lambda. As per the Bohr's atomic model, that energy is minus 13.6 z square by n square. That's the equation that we have, right? Now it will come, obviously, of course, it's in electron volts, where z is the atomic number, n is the principal quantum number or the orbit number. So when the electron is in first orbit, say E1, minus 13.6 z square by n1 square. When it jumped from that orbit to another orbit of n2 square, then the energy emitted E2 minus E1 is minus 13.6 z square by n2 square, that is E2, minus this E1, there is another minus, so minus of minus becomes plus 13.6 z1 by n1 square. So z square and of course 13.6 1 by n1 square minus 1 by n2 square is the standard formula for the energy emitted, that is hc by lambda. That's the respective wavelength of the photon. This is the concept or the formula that we are going to use while solving this problem. So what is in case 1 says, that's our problem. Electron jumps from third orbit to second orbit, that is 3 to n1 is 3 and n2 is 2. Let us substitute that hc by lambda 1, that's energy in the first case. Energy of the photon is 13.6 z square of jumping from third orbit to second orbit, that is 3 square minus 2 square. 13.6 z square, 9 into 4 is the LCM, 4 minus 9. So 13.6 z square minus 5 divided by 9 fours are 36. That is hc by lambda 1, that's case 1. In case 2, hc by lambda 2 is 13.6 z square when it jumps from fourth orbit to third orbit, that is 1 by 4 square minus 1 by 3 square, that is 13.6 z square. 16 and 9 is the LCM, 9 minus 16, that is 13.6 z square minus 7 by 16 9s are 144, that is hc by lambda 2. Let us divide these two equations, these two cases. 1 by 2 gives you what? hc by lambda 1 by hc by lambda 2. These are 1 by 2's. 13.6 z square is common for both of them, it will cancel. Minus 5 by 36 minus 7 by 144, that is hc also will get cancelled. Lambda 2 by lambda 1 equal to, minus also get cancels on this side, 144 by 7, 36 4 times 7, 20 by 7, that is lambda 2 by lambda 1. So lambda 2 equal to 20 by 7 times of lambda 1. That's the answer for the problem. That's how we solve this problem. We need to have some conceptual clarity that how do we derive equations for energy. Once if you know that, it's very easy to solve this problem. That's one question. Let's have a look at the other question. Ratio of longest wavelength corresponds to Lyman and Balmer series in hydrogen spectrum is how much? That's the question that we have. We know, first of all, we need to write an equation for this. Let's write this equation. We know the equation for the wavelength in Bohr's atomic model is 1 by lambda equal to Z square R, where Z is the atomic number, R is the Rydberg constant, of 1 by n1 square minus 1 by n2 square. You want longest wavelength. As wavelength is longest in the, of course, Lyman series, Z is 1 because we said it's about hydrogen atom. Rydberg constant of Lyman series means n1 is always 1. As the wavelength has to be longest, 1 by lambda longest has to be minimum. If it has to be minimum, what are we subtracting has to be next to that 1 by 2 square, that is R by 4. That's the first case. Right? No, it's not R by 4. Sorry, I think I have to calculate this. Yeah, what happens? R of 1 minus 1 by 4, that is 3R by 4. That's the first case. Therefore, wavelength of the Lyman series is 4 by 3R. Similarly, for the Balmer series, 1 by 2 square, and the next one is 1 by 3 square. So it will be Rydberg constant of 4 into 9, 9 minus 4, that equal to 5R by 36. That implies lambda of the Balmer series is 36 by 5R. You want the ratio of these two, lambda of the Lyman by lambda of the Balmer. 4 by 3R and 5R by 36. So it's going to be 4 nines is 36. R and R gets cancelled. 5 by 3 nines are 27. So the ratio is 5:27. That's how we solve this problem. So to solve this, you need to know this basic formula of the Bohr's atomic model. So after solving all the problems of these chap questions and atoms, it is very clear and evident that we need to know the basics of Bohr's atomic model and the formulas of the Bohr atomic model very well to solve this problem. So I'm just telling you that just get familiar with all the concepts and formulas of Bohr's atomic model so that you can solve the NEET questions quite easily. Thank you for watching.